Welcome back. In today's video, we're trying to determine the functional form of the waveform v of t. We have a amplitude of 12, and it was observed to have a value of 6 volt at t equals 1 millisecond, and it has a frequency of 4 kilohertz. The functional waveform of v of t we'll write as a cosine because in sinusoidal and AC analysis we use a positive cosine for the standard waveform. So the amplitude is a cosine times omega t, well, cosine of omega t plus or minus some value of theta. So we can then go ahead and input our 12 volt amplitude cosine. We then would want to find the frequency, and in this case we're given frequency in hertz. We want to find radians per second, and that is omega equals 2 pi times f. Thus our, well, not thus our frequency, but thus omega is going to equal to 8 pi e to the 3, which is 10 to the power of 3 radians per seconds. So that's 8 pi e to the 3 times t plus or minus theta. We then see that the waveform or the function had a value of 6 volt at t equals 1 millisecond. So thus, in our case, v of t is equal to 6 volt at t equals 1 millisecond. You give negative 3. You can just put the 1 there. So thus we go ahead and we place our 6 for v of t. And we have 12 cosine. And then omega times t, 8 pi e of 3. So if we times e of 3 times 1, e of minus 3, we'll get 8 pi. And that is going to be plus or minus theta. We then divide 6 by 12. That is 1 over 5. That's equal to cosine 8 pi plus or minus theta. We then can go ahead and look at cosine of some even multiple of pi. And in this case, well, not even multiple of pi, but in this case 2 pi. You could say even multiple of pi plus or minus x is equal to x cosine 8 pi plus or minus x is equal to x, and so on and so on and so on. In this case, we see that for our theta value, we know that for a theta value we would take, so in this case we can write that at 0.5, and that's going to equal cosine theta. And as we know, cosine, the inverse cosine of 1/2, you can look at your unit circle or you can put that in a calculator and you would get theta is equal to 60 degrees. So in our case, we can then go ahead and say, before anything, and we could have put 4 pi or whatever it is, it doesn't matter. And I should have write this as cosine x, cosine x, cosine x. So we can then go ahead and give the functional form with an amplitude of 12. Cosine, we know that's 8 pi. And let's just write it this way, times t. And our angle is positive 60 degrees, and that is equal to v of t. that's it for this problem. See you in the next one. Bye.